An estimated 100 million tons of plastic are produced each year, 10% of which ends up in the world's oceans. Areas such as the North Pacific Gyre, often referred to as the North Pacific Garbage Patch or the Trash Vortex, now contain 6 parts plastic to 1 part plankton, transforming the largest ecosystem on Earth at around 20 million square kilometers into a toxic plastic soup. Champion swimmer, sailor, and big wave surfer Patrick Furlotti is on a mission to clean up the oceans. He recently went to meet the man who first sounded the alarm about plastic pollution in the North Pacific Gyre, and the founder of the Coagulation Marine Research Foundation, Captain Charles Moore.
Charles Moore, I'm the captain of the oceanographic research vessel Algeta and the founder of the Coagulation Marine Research Foundation and Long Beach Organic. What I actually discovered was that I was passing through a part of the ocean that was littered, but it was littered sporadically. It wasn't littered as like an island of trash. It was just sporadic pieces of litter. But the point was, for an entire week, I couldn't come on deck without seeing some of this litter. And this is as far from human civilization as you can get anywhere on Earth. So I began looking at weather maps and weather faxes and seeing how this high generally hugged this area, and created a hypothesis that maybe the fact that there's so much trash here had to do with this weather system, this high pressure system. So I went back 2 years later and was able to characterize this area where I had been by going first east to west and then north to south, sort of into the center of a circle and then out to the edge again, and took those samples back to the lab and analyzed them, and found to our shock that there was 6 times as much plastic by weight as actual zooplankton in this area, the natural food that fish are feeding on. It's so dispersed it's very difficult to assess it in any meaningful way on a single cruise. What we do know is that the longer it stays in the water, the more polluted it's going to get, because plastics floating in the water, in addition to breaking down into small bits, accumulate pollutants. So they're sponges for poisons, and then transmit those poisons to the food web. So every additional piece of plastic we put in the ocean is a potential poison pill to the creatures that live in the ocean.
Patrick stopped in at the Coagulation Research Facility to take a closer look at the samples collected by Captain Moore and his team on their journeys to the North Pacific Gyre.
Director of Laboratory Research. My name is Gwen Latin, and what we do is we study plastics in the environment. Most people aren't aware of just how much plastic is in the environment, and that's one of the things we're trying to document. There's floating plastics or sinking plastics. Depending on the weight and the density of the plastic, they can either float or they can sink. So they end up everywhere in the environment, not just floating in the water column, but on the bottom. There are all different sizes of plastic. And with the natural sand and the rocks. And this right here is kind of the 2.8 millimeter size. This is a 1 millimeter size. And you can still see all the different bits and pieces of plastic that are there in with the sand. Even as you go down to the smaller sizes, yes, you have a lot of sand, but you can see all the different colored and different pieces of plastic that are in that sand. Even as you get down to the 0.5 millimeter size range, in with the sand there's a lot of different types of plastic. And when it goes even down to 1/3 of a millimeter, there's plastic in that. And it even goes finer than that. But when we get down to this size, when we sieve it out, we end up with different types of plastic that are floating right in the water that you can barely see.
So humankind is changing the composition of the earth and the seawater with plastic since it doesn't biodegrade. It's a disgusting reality.
Having met with Captain Charles Moore and equipped with a sample from the Coagulation Marine Research Foundation, it was time to find a solution. Furlotti traveled to Salt Lake City to meet Bob Herbst from H2O Technologies and conduct an experiment.
Electrocoagulation is a technology that treats a variety of wastewater streams and does a very good job, particularly on samples like we have here with multiple contaminants. I've been working with electrocoagulation technology for over 30 years, and I have 11 patents on the process. And it's particularly a good technology for removing things like we're talking about here, for particles and suspended solids in water. We've treated many different waste streams, mine drainage, oil field, from all the way from the drilling mud, from drilling the wells to the produced water that comes up as the oil and gas is being produced. We actually took oil field water from 10,000 parts per million and we took it down to less than 100 parts per billion. We did a project for the Coast Guard where they had 2 abandoned ships out on Kodiak Island. And these ships, people had pulled them in there. They were kind of on their last legs, and they pulled them in and tied them up to the pier and walked off and left them. And they sat there long enough that they started taking on water, and one of them was listing, and it looked like it was going to sink there at the dock and tear up the dock. So they decided it was time to get rid of it. But all of this water that it had taken on was now mixed with all of the bilge water and the oil in the bottom of the ship, as well as some of the chemicals and stuff that were aboard the ship. And the Coast Guard hired us to clean up this water. They made us put a boom, which is a floating absorbent pad around the area where we were going to put our water back into the bay. And when we put the water back in, around the outside of the boom, the sheen on the water from hydrocarbons and stuff from the ships that came in was such that you couldn't see down in the water. Where our boom was, where we were dumping the clear water in, you could look down in there and see the bottom of the bay. In that particular application, we went from 60,000 parts per million of contaminants down to less than 10.
So this actually is plastic gathered from the North Pacific Gyre, and Algalita Research was happy to let us use this for our experiment. This is our control sample here. We're going to send this to the lab afterwards, but this actually is our experiment here, and there's some organic debris in here, but you could tell there's a lot of what's the name of it?
Let him do that. Colloidal particles.
Colloidal particles. So anyways, I'll hand the experiment over to you.
What we're going to do here is we're going to put in the electrode into the treatment container here. Get it centered in there. Come on. And then we will add current to this to get sufficient current density for our electrochemical reaction to start happening. And you should be able to see here on the sides the fluid is being pulled in between the 2 electrode blades, and as it's pulled in there's electrons that are traveling from one electrode to the other that are going into those particles, and they're making the particles very electronegative. This will cause them to become dense and heavier, and ultimately they will start settling out. Initially here we're going to get floating material that's going to come up because of the hydrogen and oxygen bubbles that are coming up. These particles have an affinity particularly for the hydrogen bubbles because they're electropositive, and they will hold this up until the bubbles break and release. And then once that's done, the density of the material will cause it to sink into the bottom of the treatment container. There's Also, metallic particles that are being crystallized in there and becoming very heavy and dense, and they are settling right to the bottom. And so that will get dissolved metals out of this sample. What we did here was we used an iron electrode to help take other contaminants out of there that might have been in there, and then polished it with an aluminum electrode. That should give us better clarity of water, and it's definitely giving us better metal removal out of there. There's a number of the metal oxide crystals in there that are you know, sinking fairly rapidly. This is the two samples. This is the raw sample that they brought with them, and you can see these suspended particles in there that are not settling out. This is the sample that's after electrocoagulation and decanting off the clear water.